Alrighty guys, hey, welcome to Mullet Math. I am absolutely stoked to be pumping out my first video here and my first installment to a very long series, hopefully. Hey, my goal on this channel is to go all the way from pre-algebra, help you out all the way from pre-algebra, algebra, pre-calc, all the way through calculus, right? That's kind of going to be my four main installments here starting out. So I'm going to do some random videos that go into each as I go throughout. But the purpose of that is just to reach a greater audience to begin with, reach more of you guys. Which, by the way, if you haven't liked, subscribed, or followed me yet, do so, share it with a friend, or even comment some questions that you have for me if you are curious about background or whatever you want to talk about, whether it's another math question. Maybe I can work it out and put another video out. But anyways, before I actually went into some concepts and actually get into the math here, I want to kind of talk about how we approach math and what is math? What is math to me, right? Math to me is a really good challenge. I mean, ignoring the history without getting into all of that, I think the essence of math to me is challenging your brain to learn new things in ways that you're not going to learn through speech, through communication, stuff like that, right? It's more of the, I'm going to sit down, look at my page, look at some numbers, crank it out, understand how it works. But once you really understand and conceptualize and know how to apply it and know how to use it in the real world, that's what's super important. So like I said, no matter where you're at, whether it's pre-calc, whether it's calc, algebra, it doesn't matter where you're at. I think it's just important to approach math with a positive mindset and not just do the bare minimum to get through the class, but really to understand it. And even if you don't understand it, you kind of skim through it and you get to the end of the semester or quarter and you go, wow, I really didn't understand that. You find some time to kind of go back and really understand why something works and train your brain to work that way. I think it's a super positive thing moving forward in life. It just helps you think, and it's just a good exercise for your brain. So with that being said, let's just dive in. What is math, right? I think there's kind of four different steps or four different items that really make up what math is. So let's dive into number one here. The first thing I wrote out, or the way I approach math, is you have your theory or your facts, right? The factual aspects of math. And what do I mean by that? Well, example here, we have what's called a quotient rule. So if you guys have taken calculus, probably first or second week of calculus, you'll dive in, you'll be learning basic derivatives of functions and stuff and how to manipulate them, right? But really you can come in here and say, okay, we have a derivative of a function f of x over a function g of x, and you write out this whole bunch of letters pretty much that mean nothing to you if you don't understand it, and you call it the quotient rule, right? So we're told, hey, here's our teacher, they're very smart, or our professor, right? They're very smart, they taught us this, they know what they're talking about. But to us, we didn't prove anything, we don't know it. Maybe they did a proof in front of us and we wrote it out, but we don't really understand the theory. We understand it's fact and a lot of people accept it. But other than that, we haven't really dove in and understood it yet, which kind of comes down to point number two here. I think the second part of math is the conceptual part, right? Can you conceptualize it? Do you actually know it, right? Do you have the knowledge of it? So for example, do I understand the theory, right? You got to understand number one, or at least understand kind of what the point is, right? What your professor's trying to get at. Do I understand the theory and know when and where to apply it, right? That's super important. I think a lot of people going through school, they kind of skip number two and they go to number three, which we'll get to, but they skip number two. They don't really understand the theory, or they just don't understand when and where to use it. They know where to put it on the test and where to write out the answer, and they memorize the steps and how to get through it, but they don't actually know conceptually what it means, right? So I think this number two step is really, really important, even if you're in school, right? So step number three here, or at least the approach, is the solving aspect of math, right? You can actually apply it, and this is what schools test for, right? Example, can I actually use it? Do I understand it well enough to solve a problem, right? There's a problem on a test, let's say an exam, and you pull up to it and you say, oh, that's right, I remember practicing this while studying, and I can actually apply it. You skip number two, you don't understand it conceptually, but you go straight to number three, and you get through school and everyone says, wow, you got a B or an A, and you actually understand how to do it. Well, I would argue if you skip number two just to get to number three and prove that you can pass a test and get through schooling, you're not really getting all the math, and you're not really training your brain to fully understand and make sense of what you actually learned, right? And I think that's the goal. And the reason that's the goal is kind of leading into step four here. And sorry for the stitch, but now we're moving into number 4, real world problems, right? So you want to be able to problem solve and simplify. So we can take everything that we learned in our school, right? We can say, okay, that's great, we understand 1, 2, and 3, but ultimately we want to build up all of this knowledge and be able to use it and understand and conceptualize it and bring it into the real world and be able to problem solve and simplify. So it's great and dandy if you know all of this math, but if you can't do it simply and you can't problem solve in the real world, it's really not useful. I mean, it is useful to train our brains sometimes. Like I said, it's just a good workout for your brain, but ultimately we want to be able to use it at the end of the day, right? We want our education to be valuable, and we want to go into our classes with a mental state of this is going to be useful at some times, and you know what, even if it's not, let's go out and think of it as a brain workout, right? So an example of a real world problem, right? You want to find the loads applied to the trusses of my house to determine what type and how much wood I need. And wood, W-O-O-D, right? I'm not saying wood, but wood, the material. So we're going to come through and we're going to say, okay, how are we going to use math, or how are we going to use calculus to determine this? Do we even need to use math, right? Well, I would hope so, right? We have some loads on our roof. Let's say it's a flat roof, and we got a whole bunch of loads on top of it. We got snow, we got dead loads, we got people walking on it, stuff like that. So we want to determine what the loads are. So we're definitely going to have some loads, which are numbers, okay? And we're going to have to distribute that over our roof or over a truss, right? A singular truss. And we're going to say, okay, well, we can figure out where the loads are going on the walls. Let's say these are the walls, right? And we got loads here. Now, how much load or how much goes on each wall? That's what we're really after. Or how much is on, let's say, just one truss. Okay, so that's going to be my framework going into this, is saying, okay, I want to find the loads. Okay, so I think I have that written down as step 1, right? Yep. Apply applicable dead and live loads from the code book. I'm going to figure out all those loads. I'm going to figure out the numbers, right? I'm going to use math for that. A little bit of calculus. And then I'm going to go to step 2. Oh, there we go. Use calculus to find the loading on a single truss, right? So I'm going to single out one truss. And then I'm going to check all of the trusses in the cases, because you might have different trusses on your house, right? And then you're going to go through and check all of that. Make sure it's good. And then we might even, step 3, use a design program, which is typically what you see in the real world, right? You're going to use a design program to assist in the choice of wood and the quantity/size needed. And so really what I'm getting out here, guys, without getting too deep in the math, is just being able to say, okay, what did I learn in math? Do I know, oh, I learned some things in Calc 1 or Calc 2 that are going to help me with this, right? I can definitely think of integrating or using our differentiation to get our shear and our moment diagram, which you structural engineers, if you're hearing that, you understand that. But you're going to use some calc, you're going to use some math, definitely, to get this problem solved. But ultimately, guys, I just want you guys to really understand my approach to math, what I'm going to be trying to bring into every video. I'm going to be going through these steps 1, 2, 3, and 4 every single time, no matter what lesson we're in, just to really keep that idea with you and to hopefully motivate you and to understand, okay, I want to understand 1, I want to get that. I want to understand 2, really focus on that one. Go through 3, be able to solve it and be able to apply it, because that's the whole point of learning it, right? It's the points of learning steps 1 and 2. But then also, when I'm done with school or in the future, be able to go in the real world and be able to use that, right? So, hey guys, thanks for listening. Thanks for tuning in. Subscribe if you haven't. Leave a comment below if you got any questions for me, or just want to say something nice. I always appreciate that too, right? But hey, I will see you in the next video, and I think next video we are going to be talking about logarithms. So I will see you then.